So if you're asking me, for example,
this call is now being recorded.
What is the application of artificial intelligence? Let me say an example, like, Amazon Echo or Amazon Alexa is the best example for artificial intelligence. Okay. So I think now the concept of AI, ML, and DL is clear, right? Do you have any doubt regarding these three terms? If you're having any doubts, okay, just type it in the chat box. If you're clear with these concepts, then just type yes, okay, so that I can proceed. Hello? Okay, you're clear with this topic, so we can proceed. Go in. So let me make it somewhat clear by telling an example. Okay, so suppose a person comes in front of me and telling that he has given me a picture of a car and asking me to classify or ask me to find whether this picture is a car or not. So in order to understand the concept of machine learning and deep learning, what I am doing is I am just simply solving this particular problem using both machine learning and deep learning. So in machine learning, so now first I'm going to explain about the case of machine learning, what we are doing in machine learning. So we are simply taking the image of that particular car or whatever the vehicle it is, we are just taking the image of that particular thing. And what we are doing in machine learning is we want to extract or we want to take the entire physical properties of particular thing. For example, if it is a car, what I have to do, I have to first make an Excel sheet and I have to take the entire dimensions, like the diameter of vehicle or the width of bonnet, length of bonnet, or the width of door, length of door. Like all these physical quantities I want to extract or I want to take as my data. And then I want to enter all these things in the data. And after getting all these things, I am giving this to my machine. This Excel sheet, I am giving this Excel sheet my machine. So what now my machine will do is it simply go through the informations and it will tell me that it is a car or not. This is the which we are doing in machine learning. Whereas in deep learning, what we are doing is we are simply showing our machine the image. I don't want to, I am so lazy and I don't want to find all the physical quantities. I don't have time to find all the physical quantity. So I just simply take the picture and show my machine that this is the thing. You need to find the physical quantities and you need to tell me whether this thing is car or not. This is the simple difference between machine learning and deep learning. Do you guys understand till now what I have told till now? Is that clear for you? Okay, only one yes. Okay. So moving on, go in. So now we are going to look in the application of machine learning. I am pretty sure that we all are using machine learning daily. Even without our knowledge, we are using machine learning daily. For example, let's take the case of search engines. Okay, if for example, I am Googling about 2%, say first Mukesh Ambani or second one is Deepika Padukone. Okay, and after Googling for Mukesh Ambani, I have selected particular site and I am reading the entire article for about 5 minutes, say for 5 minutes. On the other hand, I have Googled for Deepika Padukone, and I just select one site and I just look into the site and I was like, okay, I don't want to read about Deepika Padukone. What I'll do, I'll simply come back to the page in which I have searched for Mukesh Ambani, and I'll take the entire page again. Okay. Now what here happened is our machine will understand that this particular person have spent the entire page of Mukesh Ambani, and just spend a few seconds in the page of Deepika Padukone. From that, what our machine will understand is this particular person is more into topic like Mukesh Ambani. So from the next time onwards, when I am just using my Google or whatever the search engine it is, what will be appearing? Recommendations will be appearing, right? Since I have been spent 5 minutes for reading the entire article of Mukesh Ambani, the recommendation might be like Reliance, Jio, Anil Ambani, or some sort of business stuff. Okay, that will be appearing the screen. If the person, even the sometimes it's like the recommendation will be like related to film industry also, but the more chances or the more percentage of recommendations will be from the business industry. That is a simple example. Likewise, the same thing is happening in Netflix, Amazon, and in social medias also. In Netflix, you will be getting recommended films or recommended series. Okay, like that. In Amazon also, if you have purchased some product, now from the next time also, you will be getting some recommendations based on that. If you have brought some beauty product, then a recommendation will be like beauty product. Okay, that like. And for the example in social media also, for example in Instagram also, each person's Instagram is different, right? Because if since I am very fond of BTS, my Instagram is all about BTS, right? But for example, just to say an example, in my case of my mother, her Instagram page is all about food recipes. Okay, because she is looking for that, and she is spending her more time in that. Because of that, her Instagram search page is all about food recipes, and mine is about what? BTS. This is a simple application of machine learning. So have you understand the application of machine learning, or how you are using machine learning daily without even your knowledge? Is this clear for you? If it is clear, just type something, okay? Okay. So, go with next. So, before getting into the topic of machine learning, we need to understand some terms. Okay, these some terminologies we are using commonly in machine learning. So, some of them are training data, algorithm, model, testing data. So, let's assume the scenario of a newcomer to a school, like a boy or a small kid who is going to school for the first time. What will be his mindset? He is not knowing anything about the subjects or some concept. He don't know anything at all. His mind or his brain is simply new to something. Brain doesn't have anything at all. So why we are bringing him to school is we want to teach him something, right? At school, we'll be providing with some notebook, textbooks from school. So we'll be particular knowledge. So let's assume the textbooks or notebook notes are getting from our school. So what is the purpose of these training data or these notes? Simply want to teach something, or this is the thing, or training data is the thing which having some data that we have to study. That is the training data. When come to algorithm, if you are looking at the algorithm, we'll be having different teachers for different subjects, right, in school. Teacher, sometimes more than teacher. Whatever the subject is, there'll be more teachers to study a lot of subjects. Likewise, here also, we want to teach something. For example, a machine. We need to teach something, a machine. But the ways are different. There are many ways to teach. And the way in which we are teaching the model or we are teaching the machine is known as simply the algorithm. Just consider this algorithm as our teachers. There are many teachers. Likewise, there are many methods or approaches through which we can teach someone. Okay. Is the two things clear? What is training data? What is the algorithm? Okay, just 1 yes. Is it clear for you? Just that means the training data is something which we want to teach, and the algorithm is the teacher, or just assume as a teacher, or the method or the process or the step through which we are going to teach that. Okay, now what happens is after our teacher teaches us all these subjects, our poor brain will try to understand everything, right? Or we'll be working more time on our subjects, and our poor brain will understand all these concepts, right? And after understanding all these concepts, our mind or our brain is quite confident that if you're giving me another question, I am able to correct it, or I am able to answer it. Like the way, if I am just making in blank brain into something which is functional. For example, First of all, I am just having a machine or something which doesn't know anything. I have given some information and the method also through which you can study. After I have given all these things, what will be my outcome? My outcome will be a fully functional brain. We can compare this fully functional brain as a model. Okay, now our model is trained. That means it can handle whatever the questions we are asking. That is exact model meaning of this model. It is functional now. So after we have studied all these stuff, what will be happening? There will be happening end semester exam or yearly exam. Okay. On that exam, what our teachers are doing, they are just trying to test our knowledge or how much we have studied till now. Simply to test our knowledge, they are just coming up with set of questions, right? And now let's compare that set of questions as testing data. That means simply to test our knowledge. That means we have now trained our model, and our model is quite confident that I can handle whatever the things you are asking me now. So, and now at that state, I am giving some another set of data to my model. Like say the last one, like in that of my school exams. And after I am giving in that, what I am asking it to do is just if you are quite confident about your study or your knowledge. Now just tell me about what these will be. These how, or just solve me for all these things. So what we are usually doing in our exam hall, we will be simply taking questions and just write the answer, and we'll be giving back to teachers, right? The same way our functional model or this model will receive all the testing data and it will give the answers. This is the actual thing happening here. Is here the terms like training data, algorithm, model, testing data. Is these terms are clear to you now? Okay, type something in the chat box. Okay. So go with next, please. So actually, what is the process? That this process I have already told you about that. Once we have prepared enough for exams, what will happen? This input data, assume it as what? Question paper. So question paper arrives. That means the input data is here. Now analyze the second figure as our teacher. Okay, what she'll be doing? She'll be going through when the peon brings us the question. She'll be taking the package and looking for whether this question is for class 9 or whether this question is for class 10, right? The same thing here also happening when we are providing an input data. This data will be analyzed for some sort of error. Someone will be checking on this for finding any errors. After, if we are not finding any errors, we will be simply giving it to the model. That means in the case of a school, after teacher checking everything, that thing will be handed over to the students. Here we will be handing over to the model. After that, we will be writing the exams, right? Similarly, here our model will be taking, based on its previous knowledge, it will decide or predict whatever the question is. Once we have completed that, we will be submitting our answer sheet. Here also, this will be delivering our output. And on the basis of the answer key, our question paper or our answer sheets will be valued, right? Similarly, here also we know the exact answer. We will be comparing with the exact answer to the outcome or the answer which given by a machine. And we just compare these two answers. If the machine tells exactly the answer to the question, we will be telling the model that this is the actual thing or this is exactly true. Whatever you have told is exactly right. Okay. If there is one more scenario, like if the answer which my machine told is wrong, entirely wrong from the actual answer, we'll be telling the machine that you have did the wrong thing. Okay, this is not the thing you have to do. So in the case of school, what we'll be getting after getting our answer sheet, teacher will be sometimes maybe punishes for getting low mark, right? Here also, if it predict in wrong answer, we'll be sending a feedback like something wrong next time. So we'll just let the machine to and learn that thing again and again. This is the exact process of machine learning. So Do you guys understand the process of machine learning? Do you have any doubt regarding the process of machine learning? Is this clear for you? Do you have any doubt regarding these topic? Okay, just one thing clear. Okay, just feel free to ask if you're having any doubt. Okay, I'm also, we are all or in same age, right? Same age group. So don't hesitate, just feel free to ask. Okay. So, okay, since I'm getting thumbs up, okay, we can move on. So going. So there are, so now we are just going to learn types of machine learning. There are mainly three types of machine learning. The first one is supervised learning, second one is unsupervised learning, third one is reinforced learning. So we know that different teacher use different method to teach us, right? Simply like that, here also machine will understand or machine will learn something on different techniques or different learning method. These learning methods are supervised learning, unsupervised learning, and reinforcement learning. Okay, let's look each by one by one. Okay, next slide, please. Okay, the first one is reinforced learning. For example, this type of learning we also did in our schooling time when we were in KG sessions. I guess when we are in KG session, we'll be having some textbook within which they'll be providing us some images. Under that, they'll be written. Suppose if it is like an image of a cat, they'll be returning that it is like this is a cat. Or if it is an image of a dog, it will be written like this is a dog. That thing is exactly happening here also. We are giving some sort of data to the machine and telling this thing that this particular stuff is this. For example, I have shown the image of a cat to the machine. I'll be telling the machine that this particular figure is a cat. So you need to remember that this particular figure is the cat and this is how the cat look like. Or if I'm showing the picture of a dog, telling the machine that this particular thing or these all are the features of a dog. Simply meaning I'm just showing some data and telling the machine that this particular stuff is this. That is actually the concept of supervised learning. So let me make it somewhat easier for you. For example, I'm having some sort of data. Here the data is actually a picture of group of cats, right? You can see a group of beautiful cats here. Okay. And below which I have a label. So what is actually label means? It is a non-response, or this is this indicate what the exact thing is, or this label indicate what the exact image tells us. So in this picture we know that this is a picture of a cat. Simply the label indicate cat. This is cat. So now we have a data. That means we have the material. So now what we want some algorithm, some type of algorithm. In case of schooling, we have the textbooks. Now we need some teacher to teach us, right? So I'll be choosing some algorithm. So now these data plus algorithm can make what? A model. We have already seen that can make a model. Here now I have prepared my model. I have trained my model. So when the exam comes, what happens? I'll be provided with new set of questions. Like this one. Here I'm showing another picture of a cat without any label. Without telling that this is a cat, I'm just simply showing a picture of a cat. So my model, what will my model do? My model remembers that this particular thing I had seen it somewhere. Oh, I have trained it since a while to identify what are the features of a cat. So my model, what will do? It will understand that this particular thing is a cat. And it will give us the output as it is a cat. This is the exact thing happening in supervised learning. We'll be providing with the data and telling the machine that this particular thing is this. So from the next time when we are giving something new to the model, it will be telling us that this particular stuff is actually this. I remember it because I had studied it. That's why I remember this particular feature is of a what? Is a cat. This is the concept of supervised learning. Is it clear for you? Hello, is it clear for you? Okay, moving on. Okay, so now comes the unsupervised learning. Okay, Unsupervised learning, we can compare when 10th standard will be, our teachers will be providing us some question papers alone without any solution. She'll be or he'll be giving us some set of questions and she'll be asking us to go and find the answer of these questions. That similar thing is here in unsupervised learning. For example, I have provided with an image of both cat and dog. In a single frame, I am having both cat and dog without any label. So without any label, I'm simply having the image and some sort of algorithm here or the method. Now this is the data and I am taking some sort of algorithm. On this algorithm, it is written that if you are getting such type of data, you have to follow some certain rules. And this is the rules which you have to follow. This is already written in this algorithm. So what will happen? This algorithm plus data will form what? A model. But if it is like, if this algorithm is written like, you need to, if you are getting such a picture, you need to look for the physical appearance. You can classify or you can divide the entire picture into 2 or 3 groups on the basis of what? Their appearance. For here in the case of this picture, this frame is having both dog and cat. What our model will do? Our model will find a certain pattern. Okay, certain pattern. We know that dog is having a particular pattern and cat is having particular pattern. On the basis of that pattern, our model will what? Will divide the entire thing into 2 different groups. Why? Because here in this picture only 2 things, that is a dog and cat. On the basis of some pattern, our model will divide cats as a group 1 and dogs as group 2. That is because simply the model is looking for some pattern, hidden patterns like similarities and differences. On the basis of some similarities or differences, our model itself is grouping. Even our model doesn't know what is the name of this particular thing. It is simply dividing on the basis of some patterns. This is actually happening in unsupervised learning. Is the concept of unsupervised learning clear? Do I need to repeat it again? So just type something in the chat box. If you don't understand, please type it. Okay. Yes, well, I am having 1 or 3 participants in this meeting and I'm just getting yes from a few. Is there any no? Just feel free to ask, okay? Okay. So moving on. So the third type of learning is reinforced learning. Okay. Let's take the example of a dog and a girl. Suppose every day I used to play with my dog. Okay, taking one stick and I'll throw it away and ask my dog to go and take it. So in that case, just assume that particular case as the case of reinforcement learning. Okay, why? Because here the exact thing what my dog and I am doing is exactly the example of a reinforcement learning. Okay, let me tell you why. Before telling that, you need to understand some of the terms here in reinforcement learning, like agent, environment, action, reward, observation. So in the case of my dog and I, let's assume the dog as my agent and I myself as environment. Okay. Now what I'll be doing, I'll be throwing the stick and ask my dog to go and take it, right? Because I am giving some orders to whom? My dog, to go and take my stick. So what my agent or my dog will do, sometime it may go and take my stick or might not go and simply sit in the same. Okay, there are 2 chances. It might go or might not go. So what the agent actually means is, it will just simply follow or just follow the order what my owner is telling to me. So in this case, the observation is what? Observation, you can see the word observation, right? For this example, the observation is go and fetch the stick. I'm asking my agent to go and take the stick. Okay. So the observation is go and take the stick. That is the question I am putting forward. So my agent will do what? It might go or might not go. Like sometimes it will go and take the stick and sometimes it will not. So that the same thing happening here. The observation is go and take the stick. So my agent, what will my agent do? It sometimes go and take. If it is going to take the stick, what I am giving him a reward. In the sense of some biscuit. I'll be providing my dog some biscuit. That is a positive reward. In that case, my dog is getting a positive reward. Okay, biscuit. If what if happens, if the dog is not moving from the position, it's simply sitting there. Do I'm going to give biscuit to that particular agent? No, I won't give any biscuit because he don't do correct properly what I'm asking to him to do. He is not doing his work properly, and that's why I'm not able to give the biscuit to my agent. In that case, I am just yelling at my dog, telling that you are just useless and I don't want to pet you anymore. That is actually a negative reward. Sometimes the rewards may be positive, like biscuit, or sometimes the reward may be negative, like yelling. So this is a simple concept of reinforcement learning. For example, now in case of machine learning, we can assume environment as be human or the programmer, or the agent as what? Our machine or model. We will be asking our machine to do some sort of work. Yes, in case of machine, it will do something, predict the correct thing, or sometimes it will not. In that case, what will happen? We will be telling the machine that this thing is not going to work. This is not the exact thing you have to tell me. This is not the right answer. That is actually the reward. This is the simple explanation of reinforcement learning. Is this thing clear for you guys? Yes. Is there anyone don't understand this particular topic? Okay, just don't type yes simply because everyone is telling yes. If you have any doubt, just feel free to ask, okay? Okay, since I'm getting all clear. Okay, we can proceed, go in. So next one is algorithm. I think I have already discussed about what is the actual term algorithm. So we can skip it. So go in. So here in machine learning, I have told you that we are using different type of algorithm, right? Or method or the set of process we want to follow. There are many algorithms, okay? And today we are going to discuss two among them. The first one is regression. So before telling about the regression, let me tell you why or in which case we are using regression. For example, when we want to predict some numeric value, or some like mathematical value like a number, whenever we want to predict some numeric value, we will be using regression. For example, let's take the example as a sales product. Okay, sale of a particular product or the price of a particular product. I want someone or my manager once asked me to find the price of a particular product for a particular month. He already had given me the entire sales list of that particular product for the past 6 months, and asked me to find the product price for coming month. So in that case, what I'll be doing, I'll be simply using regression model. Or in the case of temperature prediction. So my superior had asked me to find the temperature at a particular place for a particular day, given a set of data which include the place for the past 6 months. He'll be providing me with some of the data which will be having the details of the temperature at that particular place for some times. Okay, so at that time I'll be using what? Regression. So let's look deep into regression. Go in. Okay, so let's take the example of temperature itself. Okay, for example, I'm having my manager had given the data, and the data is as an Excel sheet. Okay, simply the data is an Excel sheet, and in that sheet I'll be having two columns. The first column is humidity and the second column is temperature. That is a simple thing. So I'm considering my humidity as here what? First input or first variable. And the first variable means I'm just considering my one column as one thing. And the second column or the temperature as what? Second thing or second variable. And now what I am having, I want to take some algorithm. Well, since we are using regression, we will be taking regression algorithm. So you just need not to worry about all these stuff. In Python, they are already written the algorithm for regression, clustering, everything. So you just can't take this particular thing. So now we are having two input, right? Variable 1 as our humidity and variable 2 as our temperature. While going through the data, we as a human will understand that as the humidity increases, the temperature decreases, or something like that. We will be understanding something. But what our duty is we want to do the same thing using a machine. That is the actual duty. So we have taken the input along with some algorithm, and what we'll be telling this machine that you need to find some relation that we have already know. That means that when the humidity increases, the temperature decreases. Likewise, a general relation. You need to find a general relation between these two inputs. Like in case of humidity and temperature, when the humidity increases or what temperature decreases, likewise, some relation you need to find between these input. After it find a relation, so you need to remember one thing clearly, that whenever I'm seeing a word relation, just imagine some mathematical formulas, right? General mathematical formulas. Just understood that these relations are some equations. So our model will find some equation. Once our model understands this equation, what we'll be doing? We will be testing it for what, or just we'll be putting some question, just like in the examination. We'll be giving some new set of humidity and ask my model to predict the temperature. This is the simple example of linear regression. We have given the data and algorithm, and our model is ready. Model will understand this entire concept, and it is now trained model. Once it is trained, I'll be giving new set of humidity and telling my model that you need to predict this thing. Okay. Is this clear? Is the concept of linear regression clear for you? Okay, is it clear? I want some more response from you guys. Yes. Oh, now when I'm just talking about just one thing, I now remember what is, when I was going through your response sheet, I saw there was a question like, do you like maths, right? Something like, do you like maths? Then at that time, what we were expecting, like we were like, okay, majority of the students will be telling like, don't like maths at all. But when I see the response, I was like, what the hell? These guys are all just what? They just love maths. And I was like, what? I don't understand why these guys are telling because they love maths. If you are asking me why do you love maths, I'll be telling that I love because just for mark, right? We have to study maths simply for mark, right? And I was just like, these guys are just love maths. And from that point, I just want to ask you a question. Do you really like maths? Like, or just you simply written yes, why? Because everyone is just saying, or some other person is just seeing my response sheet and what they'll think about me. Okay, so some boys have told that, yeah, yes, I love it. Okay. Okay. I think all you have really love maths, right? Is that so? Is there anyone who don't love maths at all? They are just, maths is not my subject. Yeah. This is not me. Okay. Is there another person who's like, maths is not my subject, for some under circumstances I have to take some this. Okay, someone is telling this love some parts of the maths. Okay, for me, yeah, I love maths just because for my marks. Because if I want, my mom will be telling that you're not studying properly, so she wants me to have to. That's why I have to love. I was forced to love maths. Okay, that's the case of mine, and you guys are really loving maths, and that's really good. So coming back, definitely not by subject. Yeah, just I know that many other students just telling that, yeah, I love maths just because why others are, what the other will think about me. Just because they are telling that, okay, I love maths. But there are some person who really love maths also. I understand that. So from some of my friends also really love maths. So according to their taste, their subjects also varies. Okay. Now coming back to our topic. So next one, Govind. So this is a simple example of a linear regression. Okay. So I have told you that in simple, I am just taking an example of a simple linear regression. That means simple linear regression. Why? Because it is having only two variables, just like the temperature and humidity. Here I am having two particular variables like weight and height. Okay. This is the real world. Suppose a real world question comes like, you need to find the weight of a particular person given the height of a person. So what there will be, first what we'll do was what we'll consider one thing, or the height as my variable 1 or my weight as my variable 2. Then I'll be choosing what? My linear regression algorithm. And together these two things will form what? Some relation between this height and weight. In here you can see, in this case you can see there's an equation called W is equal to H minus 100. This is what I actually mean about relationship. This is the relationship between W and H, right? Using the value of H, I am finding W. This is a simple thing, okay, which everyone knows. This is a simple relation between W and H. And now what we are doing, our model just find the relation as W is equal to H minus 100. Now the exams came, or we'll be giving some new questions like different values of height. We'll be providing with different values of height and asking us to predict the values of W. So what we'll simply do, we'll simply put the values of H in this equation and find the value of W. This is the thing exactly happening in linear regression. Machine will find some sort of mathematical relation, and we'll be just giving new set of data and asking our machine or model to predict the output. Is this clear? Is the example clear for you? Can I go to the next topic? Okay, just type something in the chat box. Okay, yes. Okay, one thing, just don't call me ma'am, okay? Just call my name, Amina, that's enough. I am not so aged, okay? Just don't call me ma'am, okay? Okay, go in. Okay, the next algorithm is classification algorithm. This is actually, this is also famous algorithm, okay? Like all the machine learning algorithms are famous. So the next algorithm is classification. Now, why classification algorithm we are using? In the sense, we want to classify something into some groups. Like for example, if I'm asking a question like, is the coffee hot? Then the answer might be yes or no. Or is the juice cold? The answer might be like yes or no, right? So when we are having a limited choice of answers, we'll be choosing what? Classification. For example, like given picture is a cat or dog. There will be having just two options like cat or dog. In that case also what we'll be taking classification algorithm. And now one thing you need to understand that there are actually two type of classification, that is two-class classification and multi-class classification. Not exactly two type, there are many types, but for the time being I'm just telling about the two-class classification and multi-class classification. Okay. For example, in two-class classification, let's take the example of this coffee. I'm asking a question like, is the coffee hot? The answer is like yes or no. There we are having only two choices, and that is we call it as two-class classification. And for multi-class classification, let's take the example of the second one. Are you going to office today? The answer might be like yes, no, maybe. That means we are having more than two choices, right? And that is known as multi-class classification. So moving on, next, go in. So in the previous cases, what we'll be doing, we'll be initially making our data and algorithm. Together we'll be forming a classifier model. This is the area of the exam hall, right? Once I have been prepared my model. Now what I am doing is I am giving my testing data. This is exactly the testing data. I have already prepared my model, and now I am giving the testing data to my classifier. So what will my classifier do? Since it is trained to classify or to divide such a data into two different categories, it will simply do what? Classify into two groups. The first group is as men and the second group is as women. This is a simple demonstration of classification algorithm. That means first of all we need to give some data and select some algorithm. Like classification algorithm, and together we can make some model. Once we have made this model, we will be inputting some testing data. In here, this is the testing data. Okay, this picture with both men and women is the testing data. We will be providing this testing data to our classifier model, and our classifier model will be dividing into two, like men and women. Okay, so going. So now comes the different type of algorithm, classification algorithm. There are many, but for the time being or the ease of presentation, I'm just showing these for us the examples, and I'm going to discuss about the logistic regression and decision tree. For the actual type of algorithm here is logistic regression, naive Bayes, decision tree and random forest, and k nearest neighbor. So let's begin with logistic regression. Okay, go ahead. So just don't confuse by seeing this heading. Okay, I have told you that this is an classification algorithm, and you are showing me like regression, logistic regression, but don't get confused by just seeing this heading. Why? Because we are using logistic regression just to classify a particular question into two answers. For a particular question, if we are having just two answers or just two options, we will be choosing what? Logistic regression. Like the one we have already seen, like, is the coffee hot? The answer might be like yes or no. Are you not, is the juice is cold? Then the answer is like yes or no. For in that cases, we are using the logistic regression, okay? Simply because we are having what? Two different answers, like pass or fail, win or lose, live or dead, happy, sad, healthy, sick. Like this, we are simply having two choices. In that cases, we are using logistic regression, okay? So next one is next is our decision tree. So you can see an image of an inverted tree right here, left to the slide, right? Why? Because you can see some similarities between these two things also. So why I put this thing is the actual decision tree or the actual concept of decision tree is we will be having a major question, and for that particular question if we want the answer for that main question, we need to find the answers for some other question. For example, I need to find whether a person is fit or unfit, and I want simply to find whether a person is fit or unfit. So in order to understand that answer or to get the answer, I have to ask some other questions too. The first question might be like, is the person 30 plus or is his age is less than 30? First of all, I want to know whether this person is 30 plus or his age is less than 30. That question might have yes or no. That means he is maybe 30 plus or his might be less than 30. That question might have two answers, like yes and no. If yes, that means if the person is less than 30, what will be happening? I'll be asking another question like, is the person taking pizza daily? So if a particular person is less than 30, next my question is, are you taking pizza daily? Then that particular question will also have yes, no. That means sometimes that person might take the pizza daily or not. If I am just getting as eating pizza, yes. If I'm getting the answer as yes for eating pizza, I'll consider that person as unhealthy or unfit. I consider him as unfit. And if I'm getting the answer as no, the person is not taking pizza daily, I'll consider, as far as my concern, I'll consider that particular person as fit. Okay. 4. Or the other case is if the person is above 30. The above 30 means his age is above 30. Now the next question will come to my mind is, do he work out daily or not? I want to know whether the person is having a habit of exercising or not. That particular question is also having what? Two different answers, like yes or no. Or here one mistake is, if the person exercises, if the answer is yes, then it is fit, and if the answer is no, that is unfit. Okay, there's a small correction in my PPT. If the person exercises daily, I'll consider him as fit, whereas if he is not, I'll consider that particular person as unfit. Okay, that's a small correction. So what is the main question here? The main question here was whether the person is fit or not. So for asking that particular question, I have to ask what some other questions, right? So now compare this particular thing as the tree. So what does inverse of this tree means? We'll be starting with one single segment, like trunk here, and after that it will be dividing into multiple branches, right? The same thing is happening in decision tree. We'll start with some question. I'll be ending with some other lot of questions. This is the simple decision tree. Do you guys understand what decision tree means? Okay, are you guys, can you follow me? Okay, is this confusing for you or is it clear for you? Okay, moving on. Go in. Okay, next comes our random forest. Okay, random forest, for the time being, just understand what exactly the random forest. Just as a few seconds before, we have seen the decision tree, right? A group of decision tree together can form a random forest. Like what? Like one is decision tree 1, decision tree 2, etc. up to decision tree n. Together, we can form a random forest. That means a group of trees can form a forest, right? Similarly, here also, different or a group of decision trees can make a random forest after obtaining answers or the output from the entire decision trees. We have the final answer. Okay, for the time being, just know up to this. Okay, so do you have a do you guys have any doubt till now? If you are having any doubt, you can ask. Okay, or else we can move to the poll. There's a voting session. You need to go for the vote. Okay. So do you have any doubt, guys? Or is it clear? Can I go to the polling session? Okay, no doubt. Okay, okay. Okay, okay. Okay, since you are having no doubt, we can move to the polling section, okay? So I'll be presenting my screen. Okay, this is the link for the poll, okay? Guys, just hold on. My lap is getting hang. Okay, 1 second, please.
Guys, just hold on for a minute. I have put an poll on the chat. I think you can see that on the meet.
Okay, guys, you can continue with this, Paul. Okay, now look at the meet. Okay. Now the first question is here for you. So the first question is like ML is a subset of DL. So go for it. Okay, guys, now check this link, okay? Okay, can you guys see my screen? Hello, guys, can you hear me? Please, somebody respond.
Yes.
Okay. So let's start the poll, okay? So the first question is like, which type of data is used to evaluate the performance of a model? Okay. Okay, 55 participants, 59, yeah, 64. Okay, I think we are having around 100 participants, right? 103, okay, around 100 participants. So I'm expecting some more vote, okay? So which type of data is used to evaluate the performance of a model? So the first option is what? Training data, testing data, raw data, label data. Okay. So we want, I at least want 80 response. Okay. Now it is 75, 5 more vote. So come on guys, 5 more vote. So the question is like, which type of data is used to evaluate the performance of a model, right? Okay. 78, 78, 78. Come on, 2 more. We are having around 100 participants and just 2 more votes, please. Come on, any of, okay, 79 and one more, one more. One more, one more. Okay, now it is 80, 81 participants. Okay. So the question is, okay. The right answer is testing data. It is not the training data. I have already told you that the training data is something we are using to train something, right? After training, when the exams came, what is the question or the what is the data we are giving? Testing data. And I have told you that testing data is used to evaluate the performance of a model. Okay, just don't feel bad. Better luck next time. Okay. So the next question is, algorithm contains data. Okay, 15 participants, 16. Okay, okay. 33, 34, 37, 41. Okay, algorithm contains data. 55, 50, 60, 70, okay, 64, 65. Okay, okay. And 76, 78, 78. Just two more votes. Come on, just one vote, one vote. 79, it's 79. Just okay. Okay, this answer is correct. Algorithm contains data. That is wrong. Okay, it's false. So the correct answer is false. So the next question is unsupervised learning uses unlabeled data. Okay, okay. 5, 6, 7. Okay, okay. It is rising. Okay. Unsupervised learning uses unlabeled data. Okay, 66 participants. Come on. 68, 16 and 70. 75. Okay, 77. 77, 78. 78. Just two more votes. Just two more votes. Come on. Just two more votes. Okay, just one vote. Okay, just one vote. Okay, fine. The question is like unsupervised learning uses unlabeled data, right? I have already told you that the supervised learning is using labeled data, or the labeled data simply means we are telling the machine that what particular stuff is this. And unsupervised learning, in unsupervised learning, we are not telling the machine what the exact thing is, right? So we are not using any unlabeled, we are using unlabeled data. We don't give any label to the machine. So the correct answer is true. So ML, next question is ML is a subset of DL. Okay, 29, 31. Just make it quick, guys. 50, 56, 59, 60, 62, 63, 65. Okay. 69, 70, 71, 72, 72, 72, 8 more votes. 73, that's 70, 74, 74, 75. Okay, 5 more votes. Okay, okay, just 3, okay, just 2. Just 2 more votes. 2 more votes. Just 2 more votes. Okay, 1 more vote. Last one. The last one vote. Come on, make it quick. The last one vote. Okay. So the question is like ML is a subset of DL. We have already discussed that AL is a big circle within which the ML is a second big circle within which the DL is a circle. That means DL is the simplest thing. So the answer is false. That is actually DL is the subset of ML, not ML is a subset of DL. Okay. The answer is false. Okay. That's the end of polling session. Okay, now we can continue with our session. So now next we are going to look into a small project, like just a small project. So can you guys see my presentation now? Somebody please respond. Can you see my screen? The problem definition slide. Can you see that? Hello? Please somebody respond.
Yes, we can.
Okay, okay. Okay. So the problem definition or the project or the statement we are going to solve is to predict the salary of an employee based on the years of his or her experience. The question is like to predict the salary of an employee. We want to predict the salary of an employee based on his experience. That means we are provided with some data and now we are asked to predict the salary of a particular employee. So from the question itself, we can understand one thing. What is that? We can understand the question. One thing, like we are asking to predict some numeric value, right? Salary, we know that is a numeric value, right? So what is this? So what is the thing, or what is algorithm we are going to use it? I have already told you that whenever we are coming across some numeric value, like say money or like just price or something like that, we are using what? Regression algorithm. So this, from the question also we can understand that this particular state or problem statement or the problem is based on regression, right? Is the question clear for you guys? To predict the salary of an employee based on the years of his or her experience. Is this clear now? The problem statement, is the problem statement clear for you? And the type of algorithm we are using regression here. Why? Because it is here they are asking us to find the salary. Salary is actually what? Numeric value. Okay, this clear, this problem statement. Can you just unmute someone, because I can't see the chat right now? My phone is dead, so I can't use it. I have put it in the charge. Okay, so that's why I'm asking you, please someone unmute and just tell whether you guys understand this problem statement. Okay.
Yes, we do.
Okay. So what all the things we are having? In the question itself, it is given that we are provided with the employee data set. Okay, we have, first of all, to find the salary of a particular person, we need some data set. So that particular data set may be some Excel sheet or something like that. For here, I'm considering it as an Excel sheet. Okay, and particular that Excel sheet, I'll be having what? Two columns. The first column is like experience, years of experience. That we'll be calling as independent variable. Why? Because depending upon the year, how many years a particular place, they will be deciding his or her salary. So depending on the year of experience, we will be defining our salary. That's why we experience as what? Independent variable. Okay. Now comes a dependent variable. Dependent variable, they'll be depending, or the salary will be depending on what? Years of experience. But the year of experience is not depending anything. But the salary is depending on what? The year of experience. For how many years he have worked in a particular sector. According to that, they will be deciding his salary. So we have been provided with a data set in which we are having two columns. The first column is year of experience and the second column is salary. Now, what are the tools we are going to use? Okay, the tools, like, can I ask you one thing? Are you guys, how many of you have learned Python here? How many of you don't know Python? Okay, just tell me how many of you guys don't know Python here. Just type yes if you don't. Okay, the libraries. So I think all of you are don't know. One person told me don't know. Okay, for this session I'm just using Python. Okay, don't know Python, don't know. Okay, yes, you don't know. Okay, don't know. Okay, it's okay. Okay, yeah, plenty of time. And some of our faculties later will be taking some classes regarding Python. If you are interested, you can join that also. Okay, so don't worry about if you don't Python. Okay, since I'm having limited time, I'll try to explain all these things which we are using in Python. Okay, if you're still having feeling, or if you're still feeling you didn't get the concept correct in Python, just feel free to ask the doubt me personal. Okay, just message me in personal. Okay, and I'll help you out. So here we are using Python. So in order to do a machine learning project, we need some particular Python libraries, right? So like pandas. So in this project, we are using pandas, NumPy, Matplot, and scikit-learn. Okay. for those who are not aware of this pandas and NumPy, Matplotlib, okay, just let me make it a quick review or just a list of what these things actually meant to be. So start with the NumPy. So NumPy is something which we are actually meant to do the mathematical. That means metrics. We all are familiar with the metrics, right? The metrics one we have in our maths. That is simply the 2 by 2 or 5 by 2, whatever it is. But in case of real life or in real life problems like machine learning problems, we have to deal with the multi-dimensional arrays, like multi-dimensional arrays or matrices. In that case, we are using NumPy. Since we can't handle the multi, we are just used to write some matrices in paper, right? 2 by 2 or 5 by 2. That's not actually the matrices or the arrays in machine learning. There we are having multi-dimensional. That may be 5 dimension, that may be 8 dimension, more than 10 dimension. Okay. So at that case, we'll be using what? NumPys. Simply NumPy we are using to handle large numeric matrices or arrays or multi-dimensional arrays. That is the simple thing I can tell you about NumPy. Now going to Matplotlib. I think you all have seen the graph in the textbooks, right? When we are in school, we used to see some graphs. We all will have had some sort of graph, right? And simply if we want to print some sort of graph, we'll be using this particular library called Matplotlib. This particular library will help us to draw or visualize some particular data in graphical format in order to make graphs, scatter plot, bar plot, histogram, like that. If you want to make any of these, we'll be what? We will be using Matplotlib. Now comes to Panda. I have already told you that in machine learning, especially in the regression, we'll be using some Excel sheet, right? I'll be collecting all the thing and I'll be entering the entire details in an Excel sheet. Okay. And in order to take this input, this Excel sheet as my input, what I have to do is not Excel sheet, any CSV file as an input of a machine learning program or as an input. I'll be using pandas to take such type of input, like for example, like any CSV file, Excel sheet, any of that. For that purpose, I'm using pandas. Since the data set of the employee is an Excel sheet, maybe it might be an Excel sheet, we can format as Excel sheet or CSV file, like comma separated file. So in that case, I'm using Panda. Now comes to scikit-learn. Okay, scikit-learn is something. It's also a library in which this is one of the most important library in machine learning in Python. Okay, this particular library provides us all the code, just the code for linear regression. Particular thing will contain the entire algorithm. We need not to run the entire algorithm first. So this simply making our work easy, and that is machine learning. For machine learning, the scikit-learn, we are using scikit-learn. It will be having almost all the things we need to do in machine learning. Okay, these all are the libraries we are using, and the environment today I'm here to use is Google Colab. Okay. So is the Python libraries clear for you? Okay, only one. Okay. Is the libraries like NumPy, Panda, why we are using pandas, why we are using NumPy? Okay. Now let's go to the code. Okay. So what we are actually trying to do is in this project we are trying to draw a graph like this. Okay, we are simply trying to draw a graph like this. So let's go to the Google Colab to continue with our code. So can you guys see my screen? Please somebody respond. Can you guys? Is the codes are visible to
Yes,
you?
ma'am. Yes.
Okay. Do I need to zoom this code or you can see it? Can you see these codes clearly?
A little bit.
Oh, little bit. Okay, okay. Then let me
Okay.
zoom it. Okay, now is it okay? Hello, is it now okay?
Yes.
Okay. So let's start our code. So before going to do, when proceeding into the code, there we need to import the particular libraries that I have told you later. Sorry, before, like the NumPy, Panda, Matplot. So first we are going to import those particular libraries. Why? Because here we are not writing the exact mathematical rules or steps here, right? So in order to make our work easy, we are going to take help from some particular libraries. For the first one I am here importing is NumPy. So I am importing NumPy as NP. The second one is import pandas as PD. Third one is import matplotlib.typlot as PLT. So we know that the NumPy is using to for what? To handle the higher dimensional matrices or some sort of maths. We'll be using NumPy. And for pandas, why we are using panda? We want to intake the data set. That means the CSV file or the Excel sheet we want to take. That's why we are using pandas here. And the last one is import matplotlib.typlot as PLT. Why? Because we want to finally, at last, we want to show the graph. The ultimate goal for this project is to just show the graph. Okay. And for showing the graph, we are importing matplotlib.pyplot. If you want to use Seaborn, Seaborn is another library. You can use it if you want, but I'm using, and most of the time I'm using matplotlib, and that's why here also it is matplotlib. Using Seaborn, you can use Seaborn also for making graph. Okay, Seaborn. So now I have imported NumPy, pandas, and matplot. So now I have want to take what the first step. I want the data, right? The first step of teaching something is I want data. So for that, what I am doing is I want to take my data. So let me show you how my data look like. So 1 second. Guys, just hold on.
Sure, sure.
So can you guys now see my screen? Sorry for the delay. Can you just see my
Yes, we
screen
can.
now?
We can.
Okay, okay.
Yes.
Yeah, it's visible.
Okay. Okay. So I was about to show you the data. Okay, let me open it. Okay. Okay, this is how our data first column is years of experience, and the second column is salary. Okay, this is data. Like there are three rows. Okay, how to input these data. Okay, so I am and equal to pd dot read underscore csv of this is actually the path of my data. This is actually the path of my data, means where I am storing my data. Path of so pd.csv underscore cs pd.read underscore csv. Why we are using it? It is we want to input certain csv file, and for inputting some csv file, what we are doing, we are just using panda, and that here we are import panda as pd. That's why pd.read underscore csv of that path. Okay, so after importing, so after getting the data, what we are trying to do is we are just trying to split the column. Okay, this particular column as one thing x and this particular thing as y. So for that, I have taken a variable x is equal to ds dot ilog of colon comma colon minus 1 dot values. What this thing exactly mean is we are going to select, we are going to split it. Now we want each column as in one way, in each variable, like the first column in x and the second column in y. So why we are using this ilog? We have already taken this ds, or what we know that what is the ds? ds is the data, right? We are having data in ds. So from that data, we are taking ds dot ilog of column. That first column indicate we want the data from the first row to the last row. We want the entire rows. That's why we are just simply putting a column there. Comma. Now comes our column. We want from the start, from the first column, and it's colon minus 1. That means just colon 1 minus 1. We know that minus 1 indicate what? The last thing of a particular row or a particular column. Or in case of array, minus 1 indicate the last particular element. So in this data, you can see what is the last column, that is salary. So what we are trying to do is we are just taking this years of experience column as x. And now for y is equal to ds dot ilog of colon comma minus 1 dot values. Okay, this column also indicate what we want from the top to the bottom. We want the entire rows. Okay, comma minus 1. That means we want the minus 1 indicate what? The last thing. Okay, in case of an array, we want the last element. For in case of this particular data, what is the last column? That is our date, salary. So we have taken the years of experience in x and salary in y. Okay. Do you guys understand till now? First of all, we have imported different libraries. After that, we just take the input. After taking the input, we just split each column as x and y. Is this clear till now? You can type something in the put yes, or else you can just put no. I'll repeat it again. Okay. Is that clear for you? Okay. Yes. After doing all these things, now comes our sklearn. Now comes the part of our sklearn. From sklearn.model underscore selection, import test underscore train underscore test underscore split. So I have already told you that sklearn is having most of the things we want to do in machine learning, right? So from sklearn, I am choosing the a method called model underscore selection. So inside this model underscore selection, from that we are taking what? Train underscore test underscore split. Actually, why we are taking it is we want to split. We are having a single sheet of data. Now our duty is to split this particular data into two so that we can train and test our model. For that splitting of training data and testing data from the entire data, we are using what? sklearn dot model underscore selection. From that model underscore selection, we are importing what? Train underscore test underscore split. After importing this particular thing, we are just taking 4 variables like x underscore train, x underscore test, y underscore train, y underscore test is equal to train underscore test underscore split of x comma y comma test underscore size is equal to 0 comma random underscore state equal to 1. So I have told you that why we are using this train underscore test underscore split. We know that in order to split the entire data into training data and testing data for training as well as testing. So inside that we have given what? X and Y. We know that what is the X? X is the year of experience. And what is Y? Y is the salary. After that I have given test size. Why we are giving test size? I have told that we want to split the data into training and testing data. But I haven't told that how many percentage I want us test and train data. For example, in generally we are considering the entire data as 100%, and from the 100% we are taking just the 80% of data as what? Training data. That means we are taking 80% of the data for training a particular thing and taking the 20% to test it. Okay, and this here it is indicating that this point to indicate we are taking 20% of the entire data as testing data. Say for example, I'm having 100 rows. I'll be having 80 rows in my training data and 20 rows in my testing data. And random state indicate you can take from any row. There isn't any particular order you need to take for training data and testing data. You are allowed to take data for training and testing from anywhere in the data. That is what random state tells us you. Is this thing clear now? Okay, is this thing clear right now?
Yes, yes.
Okay. So after that, what we are going to do? From sklearn, again we are from sklearn, what we are doing? We want to now up to till now we have splitted the data into training data and testing data. Now our idea is to, or our aim is to bring some algorithm, right? We want some algorithm. So for that we are using here what? Linear regression. So to get the linear regression, what we are doing is from sklearn dot linear underscore model. Actually, this linear underscore model is a class in sklearn. It is having almost all the function we want to use in linear regression model. Okay. And from that class, I am getting a function known as linear regression. And I have taken this linear regression and put it in the variable rig. Rig is equal to linear regression. Okay. I have now this is a I am taking the linear regression. What I am trying to do is I am going to train the data. Okay. Next, my purpose is train the data. I have prepared my data, input data and algorithm. Next is to train my model. Okay. That's why I'm taking rig.fit of x underscore train comma y underscore train. So why this? What is this indicating means? Now we are going to teach our model. And after teaching that, we need to take the best fit model. That means we'll be teaching the model for 100 or 1000 of time, and out of that we'll be selecting one particular model as our final model, which for predictions or further we are using rig.fit of x underscore train comma y underscore train. Okay, is this clear till now? Is this clear, guys? Do I need to explain that one more? time?
No.
Is that clear for everyone? Okay, that's Adnan Yusuf. Okay. Others, for others, do I need to repeat that once more, please? Okay. From where I want to start? Okay, you can just specify the place, or I want to repeat the entire thing. Okay. Linear, okay, linear regression. Okay. Just hold on. So, first of all, what I had did, I have an data with me, and now then what I had did, I just split the data for training and testing. We know that I need to train my little brain first. After that, I need to test it. Okay. So in order to train my data, I am splitting. In order to train and test my data, I am splitting the train data into training data and testing data. So after training it, I am simply taking my training data and I want to train something, right? Now I'm having my data, input data, but I need some algorithm, right? Linear regression algorithm. I want some linear regression algorithm so that this data plus this algorithm can make a wonderful or a best fit model or simply can make a good brain. Okay, so for that purpose, I want some algorithm. And to get that algorithm, from where I'll be getting the algorithm? That's why I'm using the scikit-learn dot linear underscore model. So from scikit-learn dot linear underscore model, I am taking what? The algorithm for linear regression. I'll be taking linear regression. Actually, this linear regression is a function. So present where? The present under in the class called linear underscore model. So actually this linear underscore model is a what? Is a class in scikit-learn, and from that class we are just taking what? This function, linear regression function. For what? Just to perform the function of linear regression algorithm. So now we have the input data, and here we are having the linear regression algorithm. So together these can form what? A best fit model. Okay, we can work with this data and algorithm and can make a good model. Okay. Megha K. Krishna, is that clear for you? Or still have any doubt regarding that? Okay, clear. Anyone else? Do anyone else is having any doubt? Okay, welcome. It's my pleasure. Okay. Do anyone have any other doubt? Okay, okay. Okay, let's move on. So after now what we have done, we have just import this linear regression to a variable. After taking this algorithm, what we are now doing is we are just trying to make the model. The process of making this model, that is actually happening here. Reg.fit of x underscore train comma y underscore train. This is the line where this is a place where we are exactly doing the process of making a model and selecting the best model out of that. Okay. So now let's take a small break. So just hold on this excitement for a little bit. So I would like to invite Akshay. Akshay, are you there in the meet?
Yes, I'm here.
Okay, now it is all yours. Come on.
Okay. First of all, I would like to ask: is there anyone other than from Kerala? Is everyone here able to understand Malayalam? Hello. Is everyone here in Kerala?
Someone please reply to him. Okay, he is one of our instructor.
If you can't understand Malayalam, please tell me. I would like to say about some things. Nobody is responding. Hello. Okay, അപ്പം okay, I will assume that all of you know Malayalam. എന്നാൽ ഞാൻ മലയാളത്തിൽ പറഞ്ഞ് സ്റ്റാർട്ട് ചെയ്യാം. ഓക്കെ, ഒരുപാട് സ്പീച്ച് പ്രിപ്പയർ ചെയ്ത് വെച്ചിട്ടുണ്ടായിരുന്നു, പക്ഷെ ഇപ്പോഴേ നമ്മൾ ഓൾറെഡി ടൈം ലേറ്റ് ആയി. ഓക്കെ, ഫസ്റ്റ് എന്നെ കുറിച്ച് പറയാം. ഐ എം അക്ഷയ്. ഐ എം co-founder of the Out of Syllabus project. And about Out of Syllabus, ഞാനും എൻ്റെ ഒരു ഫ്രണ്ട് അഭിഷേകും കൂടെ സ്റ്റാർട്ട് ചെയ്ത ഇനിഷ്യേറ്റീവ് ആണ്. Now it's working under IEDC of College of Engineering Attendee. I'm also an instructor. ഓക്കെ, ഞാനിവിടെ മെയിനായിട്ട് പറയാൻ വന്ന കാര്യം ഷോർട്ടാക്കി പറഞ്ഞുതരാം. എന്താണ് ഔട്ട് ഓഫ് സിലബസ്? ഔട്ട് ഓഫ് സിലബസ് സ്റ്റാർട്ട് ചെയ്തത് ടെക് സ്കിൽസ് പ്ലസ് സോഫ്റ്റ് സ്കിൽസ് ട്രെയിനിങ്ങിന് വേണ്ടിയാണ്. എന്തിനാണെന്ന് വെച്ചാൽ നമ്മുടെ നോർമൽ കറണ്ട് എഡ്യൂക്കേഷൻ സിസ്റ്റത്തിലുള്ള പ്രോബ്ലംസ് അഡ്രസ് ചെയ്ത് അത് റിസോൾവ് ചെയ്യാനുള്ള വഴിയൊക്കെ കൊണ്ടുവരാൻ വേണ്ടിയാണ് പുതിയൊരു വെൽ ഡെവലപ്ഡ് ടീച്ചിങ് മെത്തഡോളജീസ് ആൻഡ് ലേണിംഗ് മെത്തഡോളജീസ് ഇംപ്രൂവ് ചെയ്ത് നിങ്ങൾക്ക് തരാൻ വേണ്ടിയാണ് ഔട്ട് ഓഫ് സിലബസ് സ്റ്റാർട്ട് ചെയ്തിരിക്കുന്നത്. ഓക്കെ, നമ്മുടെ മെയിനായിട്ട് എനിക്ക് ചോദിക്കാനുള്ളത്, നിങ്ങൾ എപ്പോഴെങ്കിലും എക്സാം പഠിച്ച് അല്ലെങ്കിൽ ഒരു സബ്ജക്ട് പഠിച്ചിട്ട് എക്സാം എഴുതി കഴിഞ്ഞ ഉടനെ അത് മറന്നുപോയിട്ടുണ്ടോ? യെസ് ഓർ നോ? അല്ലെങ്കിൽ അങ്ങനെ തോന്നിയിട്ടുണ്ടോ ഇനി അത് വെച്ചൊന്നും ചെയ്യാൻ പറ്റത്തില്ല? എസ്പെഷ്യലി ടെക്നിക്കൽ ഓർ പ്രോഗ്രാമിംഗ് ലാംഗ്വേജ്, ഏതെങ്കിലും ഒരു പ്രോഗ്രാമിംഗ് ലാംഗ്വേജ് പഠിച്ചിട്ട് ഒരു 2 months കഴിഞ്ഞിട്ട് നിങ്ങളോട് ആരെങ്കിലും അതിനെക്കുറിച്ച് എന്തെങ്കിലും ഒരു ചോദിച്ചാലോ അല്ലെങ്കിൽ ഒരു പ്രോഗ്രാം എഴുതാൻ പറഞ്ഞാലോ നിങ്ങൾക്ക് അത് ചെയ്യാൻ പറ്റുമോ? യെസ് ഓർ നോ? പറ്റുമോ? അത് എന്തുകൊണ്ടാണെന്ന് ഇതുവരെ ആരെങ്കിലും ചിന്തിച്ചു നോക്കിയിട്ടുണ്ടോ? എന്തുകൊണ്ട് ഒരു കാര്യം പഠിച്ചാൽ അത് മറന്നു പോകുന്നു? അല്ല, കുറെ പേർക്ക് ചെയ്യാൻ പറ്റുമായിരിക്കും, പക്ഷെ പറ്റാത്തവർ എന്തുകൊണ്ട് ഞങ്ങളത് മറന്നു പോകുന്നു, എന്തുകൊണ്ട് ചെയ്യാൻ പറ്റുന്നില്ല എന്ന് ഇതുവരെ ചിന്തിച്ചിട്ടുണ്ടോ? നമ്മുടെ എഡ്യൂക്കേഷൻ സിസ്റ്റത്തിലെ മെയിൻ പ്രോബ്ലംസ് എന്തുവാണ്? ഒന്നാമത്തെ കാര്യം എക്സാം സെന്റർഡ് ടീച്ചിങ്. പിന്നെ എപ്പോഴും സർട്ടിഫിക്കറ്റിന്റെ പുറകെ ആയിരിക്കും പോകുന്നത്. തേർഡ്, നോ പ്രയോറിറ്റി ഓർ ലെസ് പ്രയോറിറ്റി ടു പ്രാക്ടിക്കൽ. പ്രാക്ടിക്കൽ കിട്ടത്തില്ല. ഒരു ടെക്നിക്കൽ ഫീൽഡ്, പ്രത്യേകിച്ച് ഒരു ടെക്നിക്കൽ കാര്യം പഠിക്കുമ്പോൾ, ഒരു പ്രോഗ്രാമിംഗ് കാര്യം പഠിക്കുമ്പോൾ നമ്മൾ മെയിനായിട്ട് ഇമ്പോർട്ടൻസ് കൊടുക്കുന്നത്, ഇപ്പം ബിടെക്, ഞാൻ CSC ആണ്. അപ്പോൾ അതിൽ ഞങ്ങൾ തന്നെ ഇപ്പം ഒരു പ്രോഗ്രാം ലാംഗ്വേജ് പഠിച്ചാൽ 100 മാർക്കിന് എക്സാം, അത് 30 to 20 മാർക്സ് ആയിരിക്കും പ്രാക്ടിക്കൽ. അപ്പൊ അങ്ങനെ പഠിക്കുന്ന ഒരാൾക്ക് ഒരിക്കലും ഒരു പ്രോഗ്രാമിംഗ് കാര്യത്തിൽ അല്ലെങ്കിൽ ഒരു ടെക്നിക്കൽ കമ്മ്യൂണിറ്റി വലിയ രീതിയിൽ കോൺട്രിബ്യൂട്ട് ചെയ്യാൻ പറ്റത്തില്ല. ഓക്കെ, അങ്ങനത്തെ പ്രോബ്ലംസ് അഡ്രസ് ചെയ്ത് അത് റിസോൾവ് ചെയ്യാൻ വേണ്ടിയാണ് ഞങ്ങളുടെ ഈ സ്പെഷ്യലൈസ്ഡ് ടീച്ചിങ് മെത്തഡോളജി ഉള്ള ഔട്ട് ഓഫ് സിലബസ് കൊണ്ടുവന്നേക്കുന്നത്. ഒരുപാട് പറയാനുണ്ടായിരുന്നു, പക്ഷെ ഞാൻ അങ്ങനെ ഒരുപാട് വലിച്ചു നീട്ടുന്നില്ല. ഓൾറെഡി 12:30 കഴിഞ്ഞു. ഓക്കെ, അപ്പം ഞാൻ പറയാൻ വന്ന മെയിൻ കാര്യം, ഞങ്ങൾ ഇതുപോലെ കോഴ്സസ് പ്രൊവൈഡ് ചെയ്യുന്നുണ്ട്. ഇൻ HTML CSS ഞങ്ങൾ ഓൾറെഡി ജാവയുടെ 2 ബാച്ച് എടുത്ത് കഴിഞ്ഞു. പിന്നെ ഇന്ന് HTML CSSന്റെ ഫസ്റ്റ് ബാച്ച് തുടങ്ങുന്നുണ്ട്. ഇനി അപ്കമിങ് ബാച്ചസ് മെഷീൻ ലേണിംഗ്, പൈത്തൺ, അങ്ങനെ വെബ് ഡെവലപ്മെന്റ് സീരീസ് ഒക്കെ അങ്ങനെ ഒരുപാട് ബാച്ചസ് വരുന്നുണ്ട്. അപ്പൊ അതിനു വേണ്ടി താല്പര്യമുള്ളവർ, ഫ്യൂച്ചർ കൊളാബറേഷന് വേണ്ടി അല്ലെങ്കിൽ ഫ്യൂച്ചറിൽ ഞങ്ങളുടെ കോഴ്സസ് ജോയിൻ ചെയ്യാൻ താല്പര്യമുള്ളവർ വേണ്ടി ഒരു ഗ്രൂപ്പിന്റെ ലിങ്ക് ഇപ്പോഴുള്ള മെഷീൻ ലേണിംഗ് ഗ്രൂപ്പിലോട്ട് അയക്കും. താല്പര്യമുള്ളവർ എന്തായാലും ജോയിൻ ചെയ്യുക. ഓക്കെ, ഇപ്പൊ എനിക്ക് ഇത്രേ പറയാനുള്ളൂ. ആമിന, കണ്ടിന്യൂ പ്ലീസ്.
Thank you. So let's continue with our topic. Okay, let me present my screen. Okay, can you see my screen now? Okay, can you see my screen? Please somebody respond.
Yeah.
Just me, guys. Okay, so we have up to till now we have just selected the best model, right? So now our model is just became a functional model, or it is trained model. So what happens after the training? We'll be starting. Okay, we'll be asking for this is the next thing. So for that I have been using red.predict x_s. That now you're focused to, you need to predict this particular thing. Values of this is x test. Okay, I have already split the x test. So now I am passing that x test into this particular line, saying that now you have, since you have studied this entire thing, now it's your turn to test it. So, and I'm asking to predict it. So what will be my y value? My y value will be having some sort of numbers. So my ultimate goal is to show this particular value, y value, along with this x value in a graphical form. So till now I have predicted my value. I have come up with the value. So now my next duty is to show this particular thing as a graph. For that, first of all, I am just using plt.scatter. That is why, because we want first thing we want to scatter some of dots here and there. Okay, that thing we are using. So for that, plt.scatter of x test comma y test comma color equal to blue. Here this x test indicate the value for x-axis and y test indicate the value for y-axis, and the color indicate the line of the color of the graph. That means we know that since it is a scatter plot, there will be so much points, right, scattering here and there, and the color of that scatter will be blue. Okay, and for the next thing, I have already shown you the graph of a graph which is containing so much points and a straight line. Okay, so now we want to draw that straight line. For that, what I am doing is I want this PLT. I am just using PLT.plot of extreme comma reg.predict of extreme colon color equal to blue. And here also I am using extreme as my x-axis, and for the y-axis I am using reg.predict of extreme. I am asking the model to predict the value using x underscore train. Taking the x train as input, you need to predict some value, and that particular value I am using as y-axis. Here the color is blue. Okay, here the color is blue. Now I am using plt dot title. Okay, well, now comes to what is a title. Title means when we are seeing a graph, that graph, sometimes that graph may have some heading like this is the particular graph indicating something like this is a graph indicating salary versus experience. Okay, in order to give the title or just to give the heading for that particular graph, I'm using plt.title of salary versus experience. And x label, next is the x label and y label. So plt.x label means to label the x-axis to indicate what the x-axis says. Inside that you can give what the x-axis actually is. So here my x-axis is years of experience. So I am just giving it as years of experience. Similarly for y-axis, what I am doing is my y-axis is what I want to predict the salary, right? So I'll be taking my salary as my y-axis, and to label it I'm using plt.y label of salary as salary. Salary is the thing which I need to show. After doing all these things, what now I need to show the answer, right? Now I need to show how the graph look like. That's why I'm using plt.show. When you're using this particular thing, the graph will be displayed. Okay, this is the code, and now I'm going to run this particular code. Okay, you can see the graph, right? Can you see the graph clearly? Please somebody respond. Can you see the graph clearly?
Yes.
Okay, so this is the graph, this is the regression line. Okay, this line is called the regression line, and this is the scatter plot. Okay, actually the regression line is the predicting. So for any further case, if you are giving some input and asking that machine to predict a value, it will predict a value something around this line. Okay, something which is near this line. So, but this, what is, now you are asking me, what is this blue dot? This is actually the original value. Since I'm splitting the data into training data and testing data, for the testing data, I know the exact answer, right? And these dots are the exact answers, and this particular line is the predicted value. That is, this particular line is the predicted value, and the scatter plot is the original value. Okay, on the basis of the distance between these two, we will be deciding whether to stop or to run it again and again. If it is quite good, we are just stopping it as right here. Okay, so this is the graph showing salary versus experience, and this is the thing our model have predicted, that this is the predicted regression line, and this is the actual one. Okay, do you guys have any queries or doubt regarding that? Is this thing clear for you? Is there any doubt? Hello? Am I audible?
No, ma'am.
Okay.
No.
Okay. So for everyone, is there No. Is there any problem? Vishnu, do you have any doubt? Oh, okay, it's clear. Okay. So you will be having an opportunity to submit this particular code, right? Okay. You will be having a chance to show this particular, okay, to submit. If you are submitting, we'll be providing you some opportunity to submit this particular code, and if you're completing this particular code, you will be getting one another certificate also. So just go through the code once again. First of all, we have imported every libraries, and second thing, we have just what took the input, just separated the columns. After that, we separated the entire data into training data and testing data. After that, we have taken the algorithm like linear regression. After taking the regression, we just combined this data and regression to make what best fit model. After making best fit model, what we did was we just asked it to predict the value for the new data. After predicting it, we just tried to plot the graph here. Okay, is this clear now? Do you have any doubt regarding any of the topics that I have taught you today? Is there anything? Okay, if you have any doubt, you just write it in the chat. Okay, if you haven't any doubt, you just write yes or no. Okay, so that I can understand. Okay, clear. So that's all for today's session. Thank you all, guys. Thank you for your wonderful support. So, and we'll let you know about the further details of the session. We'll be providing you some of the opportunities to submit this assignment. And also, we'll be putting you to some WhatsApp link, and from there you'll be separated to different group according to your risk. Okay. So further details will be sent through the WhatsApp. Okay, thank you so much once again. Thank you so much all for your wonderful support.
Please don't leave. We have sent a post-session analysis form to the WhatsApp group. Please make sure everyone fill that. Okay.
Okay. Okay, just don't forget to fill that particular form. Okay.
Okay, thank you everyone.